As you may notice, I've got this new background. We're having some work done where the computer is usually, so I've got this other temporary background. Just wanted to acknowledge that. So in this video, I'm going to be going back and giving you a little bit more information about the element hydrogen than I did in my previous hydrogen video. And I'll also be doing some cooler, in my opinion, cooler reactions with hydrogen. Combustion reactions, which are always fun. Hydrogen is the most abundant element in the universe, no matter how you measure it. And it's also the simplest element, with the most common isotope just having a proton in the nucleus without any neutrons. The thing about hydrogen is that it has only one proton, and therefore a neutral hydrogen atom only has one electron. This puts it in a separate category from any other element. This other category is that it has an unfilled valence shell, but its valence shell will be filled with only 2 electrons as opposed to the normal octet or 8 electrons. What this means is that in some ways it acts like alkali metals, which want to give up 1 electron and form compounds, but it can also act kind of like the halogens, which want to take another electron to make compounds. It can go either way, and because of this, its electronegativity and ionization potential is right in the middle. So it's not a very reactive element, even though it can act both like halogens, which are really reactive, and like alkali metals, which are really reactive. Hydrogen is so common that I can't really talk about, oh, it's used as some alloying agent, for steel to improve various qualities of it, because in pretty much any application you will find hydrogen. It is essential for us to survive, for humans and all living beings to live, because water is necessary for life as we know it, and water is H2O. It's necessary, it's an integral part of all organic and inorganic chemistry in many cases. So, with all this said, I'm now going to show you how you can isolate hydrogen in the lab without too much complicated equipment or chemicals. It's hard to buy commercial hydrogen gas. The stuff I make today is going to be pretty impure, but plenty pure enough to do some really cool combustion reactions with. Additionally, if you want to dry it out, you can pass it through a tube that's lined with something hygroscopic, such as sodium hydroxide, which will absorb any water vapor and HCl gas that's left over. Let's head to the lab. Okay, in my previous hydrogen video, I did show hydrogen burning, but I did not show the classic blowing up a balloon filled with hydrogen. So that's what I'm going to do this video. I'm going to start out putting a very small amount of aluminum inside my Florence boiling flask filled with HCl, and we will get, after a while, after it eats through the oxide layer, here you can see the reaction is starting. You will get a double displacement reaction where we get hydrogen gas and aluminum trichloride. So right now the hydrogen gas is actually being evolved and going through my little contraption, filling up the balloon here. Now this was a very quick reaction. I'm going to put in a little bit more next time so that it actually has time to hopefully fill up the entire balloon. We'll see how that works out. Many times when I was igniting the hydrogen balloons that I made, I felt heat from the explosion, but it could be that the explosion is so fast that it can't be caught on camera. But for some reason I can't actually see flame on the camera, except for this one. In this example, although I felt a lot of heat, when the balloon exploded, and the sound was a lot louder than that of a partially inflated balloon simply popping, the reaction, I assume, just happened too fast to be caught on camera, and you never see a really good cloud of flame like you do in the previous one. I thought I'd show it to you anyway, since the sound is pretty impressive, but not nearly as much as real life. One.